We now solve this indefinite integral. That is, we have to integrate the expression 3 over under the root of x times 1 minus cosine of under the root of x times dx. First, I'm going to rewrite this in a different form. That is, I can write this as integral of 3 over 1 minus cosine of root x, and this is multiplied by dx over under the root of x. I'm just bringing this root x in front to dx over root x. Now let's solve this integral by substitution method. So I'm going to put root x equals t, and we take the derivatives on both sides. The derivative of root x is 1 over 2 root x, and then dx, and this equals dt. So we now solve for dx over root x, that is dx over root x, and this equals multiply both sides by 2, so we get 2 dt. And so therefore, if you observe the original integral, we can replace this expression dx over root x as dt, and then since we are making this root x equal to t, we just have to replace this root x equals t. So let's rewrite the given integral after we made the substitution root x equal to t. So therefore, the original integral is written as, we have this 3, so I can put this 3, and then divided by 1 minus of cosine of root x. So I write 1 minus cosine of root x is replaced as t, so it becomes cosine of t, and then times dx over root x we have, which is replaced as 2 dt. So I put 2 dt here. Now let's simplify this. So this equals, we can multiply this 3 with the 2, which gives 6. I factor out the 6 out of the integral and then write this as 6 times of integral of 1 minus cosine of t dt. So basically we have to integrate 1 over 1 minus cosine of t. And for this, I'm going to make this trigonometric substitution. That is, we can rewrite this 1 minus cosine x as 2 sine squared x by 2. So this is from the double angle formula. We have written this 1 minus cosine x. So in the same way, if we do the substitution here, we can rewrite this integral as 6 times of 1 over 2 sine squared t by 2. Basically, we have rewritten this expression 1 minus cosine t using this trigonometric substitution, 2 sine squared x by 2. So therefore, this is 2 sine squared t by 2. And then we put this dt. Now we can factor this 2 in the denominator. That is, this will become 6 over 2, and then integral of 1 over sine squared t by 2 dt. And so this becomes 6 by 2 is 3. So I put 3 times of integral of, remember that we can simplify this expression as, if we use the reciprocal identity, that is 1 over sine squared x, and this equals cosecant squared x. So therefore, if we replace x by 2 here, this will be cosecant squared x by 2. Or if we replace x by t, this will become 1 over sine squared t by 2 will become cosecant squared t by 2. So that's what I'm going to do here. So this is written as cosecant squared t by 2, and then dt. And now we use the standard integration formula to integrate this expression cosecant squared t by 2. That is, this is according to the formula integral of cosecant squared x dx, and this equals negative of cotangent x plus the integration constant c. So when we use this formula, we can write this as 3 times of integral of cosecant squared t by 2. So it is negative of cotangent. Here we have t by 2. So I put this as negative of cotangent of t by 2. And this has to be divided by the derivative of the t by 2. That is, the derivative of t by 2 equals 1 by 2. So we divide by this number, and then we put this integration constant c. So let's simplify this. So 3 divided by half, which equals, we can multiply 3 with the reciprocal of half, which is 2 by 1. So this becomes 3 times 2 is 6. So I can put this as negative 6 because we have a negative here. So it becomes negative 6 times of cotangent of t by 2 plus the integration constancy. Now we have to replace the value of t. That is, we do the back substitution for t, which is root x. So when we do that, we get this equals negative 6 times of cotangent. T is replaced as root x, and this is by 2, root x by 2 plus c. So therefore, this is the result of the given indefinite integral. That is negative 6 times of cotangent of root x by 2 plus integration constant c.